And where did my URL go? Is it up here?
Just
Can I ask Ian to find it? Hey, Ian. Will you find it's called DOBC pipe configuration management on YouTube. It should be a video.
yeah.
Will you find it and put the link in channel? And then we're going to do last week's.
Configuration management, I'm ready to go.
Yeah, it's the live stream. Should be the most recent one. There might be like 3. So we're currently off air. So let's wait until we're on air.
Oh, I think we are on
You're
air.
on there.
Yeah.
Cool.
All right.
This is Jordan.
Uh,
Or this is last week's. Okay, I'll let you do last week's and then I'll let you do Jordan's.
Cool. All right, guys. We're ready. Finally.
Your attention, please.
The long-awaited configuration management presentation. So,
We're only like 4 minutes late. This is awesome.
we started a timer for
Yeah.
5 minutes.
5
So
minute timer starting.
now-ish.
Hold
All right, so we're gonna go over last week's slides really quickly. We have a 5-minute timer going just so that we don't like get off on a tangent and go way over as we tend to do.
Let's plenty of time for tangents.
Okay, so for those of you who weren't here last week or listening online, configuration management is basically the idea of like managing several servers, machines in general, in a certain way. So like say that you're Google and you have a gabillion different machines, and all of a sudden there's a security update where people can get other people's banking information really easily off of your servers. And you need to update them. You can either go around to each individual server and manually update it, like saying, you know, install this new version of, I don't know, Apache or something. Or another thing that you can do is use one of the configuration management tools we're talking about to talk to all of your servers at the same time and update them all at the same time. That's one example. Does that kind of make sense to people? Like just
Does the usefulness of that make sense? Cool. The fact that you don't need to hire 50,000 interns to manually update things. You can just have a piece of code that says, hey, upgrade this version.
yeah. Or if I need a new server, I can just say, hey, make this look like that.
Yeah.
Really easy. So a brief history of configuration management. In the 1990s, we had snowflake systems. That's what I just talked about, where like each server was like different and we had to update them all manually. And when you have like 5 machines, that's totally fine. But again, we are Google, that's not really plausible. So then we saw the rise of Unix-like systems. So that's basically Linux, and then Macs are also Unix compliant. And this increased the need for, again, more large-scale stuff. CF Engine was the first configuration management. However, now it's pretty old and crotchety. There are much better tools. It'll work, but like we wouldn't recommend it. And now a lot of other configuration management software has emerged, which we will talk about a little bit. I think I already said most of this. So this is some of the uses of configuration management. I gave you one example, which was really quickly updating a system. But you can also use it to, like I said, create a new machine, ensure the state of any given machine, repeatable way of rebuilding a system. So if you lose your entire system, say there's a fire or something, then you can rebuild it really easily. Okay, so current configuration management platforms, that's essentially the software that you use to do what we're talking about. The first one's CF Engine, which I already talked about. The second one is Puppet. It consists of a declarative language. So it's basically like you would write a script that says like, it's a series of declarations. It's kind of what it sounds like. Make this server look like this. Make sure it has Vim installed. Make sure it has GitHub installed, etc. And then this client server paradigm that it's talking about, the idea behind Puppet is that there's a single Puppet master or server, you might say, and it knows what's up and it broadcasts out to all of the clients or nodes or other servers. So Puppet master, they call them puppets. Haha. Does that make sense? Yeah.
If anyone's lost, just say, hey, I'm lost. And we will extend the time for you.
The next one.
Okay, that's real, by the way.
The next one that we'll talk about is Chef. and that's what I'm going to be going a lot more in depth into today. It's also written in Ruby as well as Puppet, so get to know Ruby.
It's not written in Puppet, it's written in Ruby. Like
Yes, like that.
Puppet.
It also follows the client-server model. Chef and Puppet are definitely the most most widely used of the software we're talking about. So if you're looking to go into system administration, you'll likely encounter one of the two. Just things to keep in mind. And then Ansible is another pretty cool, actually, configuration management platform. And it actually uses SSH. Oh, cool. It uses something really cool. Here's a Puppet example.
Learn about all this. This is just a quick review.
Here's a Chef example. Here's an Ansible example. You can see all these. If you go to that URL, except change the 14 to a 13. This is where the slides live. Sieve Engine scales like mad, but maybe not the most agile. I don't know. They all have their pros and cons, honestly. Can I go over push versus pull real quick?
Do it.
Okay, so there's a push versus a pull model. So we talked about the client server, how there's like a Puppet master and the puppets.
Sorry, the way that works is there's a server, and then the clients all have a daemon, and the daemon sort of checks in with the server regularly for the pull, right? Or is it the push?
Yeah. No, pull, yeah.
Yeah, with pull. So there's a daemon, which is just like a persistent program running on everyone's computer, and that program checks in with the main server and says, hey, do you have any updates? Hey, do you have any updates? Hey, do you have any updates? Right?
Yes.
And then if it does have any updates, it'll say, yes, I do have an update. Here you go. And the Puppet is like, woo.
The other version is where the server, once it gets an update, pushes it out and like pokes all the nodes and says like, hey, I have an update. And the node is like, okay, I'll accept your update. So that's the difference between pull versus push. They each kind of have their pros and cons. Yeah.
They're both pretty equal. We wouldn't be talking about both of them if they weren't like both viable options.
Yeah, if one was better than the other, they would just use it.
Yeah, if like push was like objectively better, we'd just be like, yeah, some dudes tried to pull and it didn't work. This stuff.
All right.
Cool.
Excellent.
So moving on to this week's curriculum. If you were confused about anything today, or you want to review or look at some of the examples more in depth, look at the documentation for the various configuration managements we talked about: Puppet, Ansible, CF Engine, Chef, or check out the slides.oscosl.org. We're going to them apparently. Yeah. So today we're going to go over Chef basics. So basically we're just going to try to solidify our knowledge. So instead of talking conceptually, broadly about each of these tools, we're going to really talk about one tool, which you do, and those.
I'm making sure that this is the right slides. I think it is. Well, okay, so his thing is in this format. And I recall looking at it in slides format. I don't recall how.
You can also just comment it.
Yeah. All right, ignore the man behind the curtain. Oh, can I clone the repo?
So are there any questions before we go into what Chef is? Does anyone know what Chef is or understand based on what we told you? Are there any questions even like, why is there food involved? I thought this was a computer class.
Why is it called Chef?
Because people love puns and terrible naming schemes. Here we go. Imagine this. I go on a branch. I take the opportunity every time I get it. So you're using a tool called Chef. Chef also uses a tool called, to test things, it uses something called Test Kitchen. Test Kitchen uses something called Knife. And when you're testing, it's cookbooks. And each cookbook is a pile of recipes. Try Googling for any of those problems. The odds of getting the technological result in Google is like almost none. I think I have a screenshot of someone that's like knife kitchen cookbook recipe problem, and I just got a bunch of cookbook. Like Amazon came up and it's like, hey, you want to buy some cookbooks? I'm like, no, I don't want any knives. So they love their naming scheme. Puppet is a little better. Chef used to be better because they used to be a company called Opscode. So you could just say Chef, Knife, problem.
Ops code.
And it's ops code, and it would be like, hey, you wanted a chef thing, not a like cooking thing. But then they changed their name to chef, so now it's just all out the window.
There's no slides. Oh my goodness. This is terrifying. There's no slides in the build.
Did you try to make slides?
I did not. That would have been smart.
Good. Hey, next.
Oh, I think this is it. All right. On the road again.
Great. You might have So today we're going to go a little more in depth into what chef is. The curriculum that we're covering is something that one of our coworkers, Jordan, covered. He's been to class a few times. He's taught a few lessons. He's not able to be here today because he has a life. And a child. That's the more important part. So basically what we're going to do is we're going to use what he wrote to try to teach you guys. So I'm not really sure how far into this we're going to get. We're just going to kind of go. If you guys have any questions or you want to like take a break.
Or if you want to like learn about something else even, we kind of covered the essential part, which was covering last week's material that I forgot to do in video. So if you guys are like, hey, I'm in CS 162 this term, and I have this really hard question that's really bothering me, like either a conceptual question or just want to like learn more about C, we're all pretty knowledgeable if you guys have any questions.
Yep. So we're just going to cover this for a little bit, and then we'll take a pulse and see how we feel. Some of this is going to be kind of OSU, OSL specific because it was sort of meant to be like an internal presentation.
The OSU, OSL is where we all work.
Yeah, it's what hosts this.
Yeah.
So here's basically the workflow. Or rather what we're going to try to cover. We're basically going to try to see how Chef works. Like one cool thing about Chef and sort of why it was made was that you can actually embed Ruby in Chef code. So this is kind of useful because Puppet just uses something called a
domain-specific language.
Domain-specific language, which is sort of like they made their own language for configuration management. But with Chef, you can kind of just write Ruby and it'll just sort of work.
Which if you already know Ruby is pretty awesome, actually. You just don't have to learn this whole new tool.
So,
yeah, and we'll kind of go over, there's a lot of tools that are used for development. So like writing tests, what's the testing framework for Chef? Is there a development kit? All these questions will kind of be answered by the tools commonly used for writing Chef, and also stuff like linters that are used in Chef that make writing code a lot easier, stuff like that. And then also like Ruby can be a little strange sometimes. Support for Ruby, for each version of Ruby, actually stops after 1 year, which is pretty, if you're not very familiar with the software ecosystem, that is incredibly fast and annoying sometimes. So Ruby has a few oddities, just syntactically and also kind of based on that a little bit.
Yeah. And by the way, quick side note on the whole like Ruby thing, Ruby doesn't support versions of its language after 1 year, but communities will just sort of support their own version. So they'll say like, we use 1.9.3, and then for like 5 years, that's the version they use. And then later they find the newest version that's patched well and works, and they say, okay, now we're gonna upgrade to this.
So it's not total chaos.
It's not it's pretty close though. So yeah, go for it.
So some pretty common terms. One that we mentioned was client. So I know that was something we mentioned earlier in terms of the client server model. Like you, in this case, it's like a, I don't know, not the chef master, but what would you call the main?
I just called a master. That's sort of what it is.
Okay, there's like a master server, and it has to talk to all these other servers. But you want that communication to be secure. So that's what the sentence about identifying what a key pair is just saying like everyone here is authorized to talk to each other. And there's a client server model. So that's essentially what that means. A node is kind of the same as a client actually, or we refer to them very similarly. Take the last two.
Yeah, sure. So I'm gonna skip the knife one for a second. Bergshelf is a pretty cool tool. Essentially it manages
it manages Ruby packages. So there's like pip for Python packages. There's gem for Ruby packages, and Burkshelf manages like installing a bunch of versions of different gems. So you have like something called a gem file, and if you run like burks install, it'll basically install every they're called gems, and every appropriate version of each gem. And then Knife is basically a tool for interacting with Chef Server. We're actually going to get into that a little bit later. So yeah. And this is some more terminology. Food Critic is a linting tool. Who here knows what a linting tool is? Or what the concept of linting is? Who does not know? Cool, we got some hands. So linting, do you want to cover this one?
Oh, sure. Linting is essentially, many languages have something called standards. So for example, how many of you guys have written like C code? Excellent, pretty much everyone. You know how you use like curly braces and your comments kind of have to be a certain way, like at maybe the top of the page they have slash stars and I don't know. That's kind of a poor example, but like long story short.
One common thing is there's a great debate in the world of C code, whether you should have your function definition space and then an open curly brace, or your function definition and then your open curly brace on a new line. And people get up in arms about this.
Okay, this is the obviously wrong thing to go on about. So essentially,
What a linting tool does is it just goes through your code and makes sure that your code adheres to agreed upon coding standards. So kind of a better example of a programming language that has pretty strict and rigid programming guidelines is Python. So Python, like, you have to have 4 spaces as a tab, and white space really matters. So you have to have your file configured a certain way, and anything over 80 line or over 80 characters on a single line is kind of not part of the coding standard. Stuff like that. Food Critic and Rubocop are ways of making sure your code adheres to those standards.
Linting tools also do really handy things, like they will check to see if you are using a variable without defining it first, or you forgot to include package. It can save you a lot of grief.
Yeah, and debugging.
So not only does it make your code really pretty and make sure that everyone's writing the same pretty code, it's also ensuring that you don't make stupid mistakes before you run your program.
yeah. So essentially, a linter, just to end it, it sounds very similar to like running your code and just seeing what the compiler says, but it does a little more. It does all of the error checking that a compiler would do, as well as style guidelines. So it checks to make sure that your code adheres to some unified style. Ruby and Python both have pretty unified styles. Depending on your language, the strictness of those style guidelines will be a little different. And yeah.
That makes sense.
Yeah. Food Critic is specific to Chef. Rubocop is specific to Ruby. So Rubocop will give you sort of general Ruby style guidelines. Food Critic will give you Chef guidelines or feedback, I guess. Even more terminology. So Test Kitchen is, who here knows what Vagrant is, or a virtual machine? Those are both sort of the same thing. So Test Kitchen is a really cool tool for testing your cookbooks that you create. And a Chef cookbook is just, like we talked about with configuration management, it's just a set of code that
Defines how a server's state should be.
yeah, so it says that you have a code block that says, I want to install Apache, and another code block that says, I want to install Vim, or another one that says, I want to have a user, and another one that says, I want to install pip 2.7, and I want to install these packages with pip, or sorry, Python 2.7 and these packages with pip. And Test Kitchen is sort of how you would test your cookbook. It's a way to locally run your cookbook, basically the code block that you've created, and a way to just sort of test to make sure it'll work when you push it out to your 10 million, billion, gajillion servers.
And it uses virtual machines in place of quote unquote real servers. So you don't have to have an entire data center in order to test your cookbook.
Yeah, you can just test it locally on a virtual machine, usually using Vagrant, which is a really easy virtual machine tool. If you want more information on what Vagrant is, go to our slides at devopsbootcamp.osuosl.org. There should be information on the side. Server spec is a testing framework. So essentially it's, you use server spec to write tests for your code. I'm not really even sure how to expand on that. Who here has ever written tests for their code? Like you had a class assignment and you had to write programmatic tests so that you didn't have to manually enter the numbers. Okay, so server spec does that. Essentially, it you bring up your code with test kitchen, and then you run kitchen tests or kitchen kitchen verify, I think, and it runs a testing framework. So it's basically a block of code, one block of code that says, hey, is Python 2.7 installed? Another one that says, hey, is Apache installed? Another one says, hey, this file that should be created, like you know that this file should be created, was it created correctly? And that's just really useful just so that you don't need to manually log into each machine that you create when you're testing. You can just tell the computer to make sure that everything is working properly. So Ruby, who here has ever written any Ruby? One person, 2 people, 3 people, 4 people. Who here has not ever seen Ruby code? One person.
Who's written Python?
Who's written Python?
Okay.
It's pretty similar. It's pretty close. Except dumb.
We're gonna say they're similar but different. But like think of rectangle and square. Like they're fundamentally different, but kind of not.
I don't know what she's talking about.
Perfect analogy. All right. Anyway, but so one thing that Ruby has in common with Python is that it uses white space.
No, it doesn't.
No, it doesn't. Well, it doesn't use brackets.
It doesn't use brackets, correct.
So let me rephrase that. Ruby doesn't use brackets most of the time.
You know when you run Python code and you're supposed to have 4 spaces, but instead you did 5 and it says, everything's broken. That doesn't happen in Ruby, but you don't have the ugliness of brackets. It's supposed to look really nice, but not be so stringent with the like, you have to do the spaces right.
So who knows what this first bullet actually means? Dynamic, strongly typed. We'll even ignore the last half of it. Just like, what is dynamic and strong typing? Maybe.
You have to declare a type,
Yes.
but there's different types.
Yes.
Not everything's an object.
That
I
was
guess everything's objects.
that's pretty good. So the idea of dynamic typing is that you don't have to declare what a type is. It's implicitly passed. So like, you know how in C you have to say int myint equals an integer? In Ruby, you don't have to do that. It will look at the number 11 and be like, oh, I know that that's an integer. And if you want to float, it will say, I will make that a float. So that's really nice, but strongly typed means that once a variable has a type, it will not very easily change that type. So like Python is kind of duckly typed. If it walks like a duck and talks like a duck, it is a duck. And Ruby's a little less like that. It's a little more rigidly, if you declare something as a float, say, it will not change it to an int. What are you looking at me like that for?
So let's move on. So this first code block, can we just, who knows what this code block is doing? Best guess.
Printing the array.
Yes.
Don't declare above it.
Yes. Ding, ding, ding. And who knows what this code block does?
Go for it.
Same thing.
Yeah.
So this is a little bit of special Ruby syntax. It's sort of,
Puts means print.
yeah, puts means print.
That's one of the hardest things to learn.
Yeah, and basically this is just a separate syntax for the same thing. The bottom one is Ruby syntax, the top one is Python syntax. I think that,
This do end is usually how you declare a function.
yeah, so instead of brackets, you have do and end, which is, might be better, might be worse. Oh, and actually the really cool thing is the pipe x pipe basically just means we'll go into better examples for that, but essentially it means
This is where you establish what X is going to be. So you're iterating through, like here you're iterating through an array. And then
each element in the array is denoted as X, which is really useful with more complex examples. For this one, it's pretty simple. But the pipe X pipe is used a lot in Chef for iterating through lists of like packages, for instance, for like installing a bunch of packages. Actually teaching Python compared to Ruby compared to Python is really useful.
Yeah, so you know, just like defining a function looks pretty similar. Maybe there's no colon, but like you've seen this before. A return statement, again, puts is like the hardest part of understanding this. So you're like, there's no print, but like puts is print. And then notice that there's no parentheses.
the parentheses are optional.
Yeah.
Something to keep in mind. Ruby, for some reason, really likes to look pretty, which, you know, it looks pretty. But yeah, it implicitly takes the arguments after the function. So right, like there, if you just wanted to call a function and it had 4 arguments, you would say, you know, function name, and then argument space, argument space, argument space, argument space.
If you didn't provide enough, it would just say an error, like, hey, you didn't provide enough. If you provided too many, it would just ignore anything after the first 4.
Right.
And you would have to know, like, oh, this isn't working because I messed up.
So if you said sum 3, 5, 10, it would just return 8. It would just print 8 and then space 10, I believe. So is this making sense? You have to sort of understand the fundamentals of Ruby before we can jump into Chef, because Chef is a lot of Ruby. Go for it.
Oh man. I don't even know that I know what the Ruby's doing, actually. Ian, do you want to take this?
So it is for INX.
To clarify,
Okay, so-
these are both,
Oh, I get it. I know what this is doing. Never mind. Okay, so Ruby has this thing called implicit return, which, like, I prefer explicit because I don't really know the implicit return system very well. They're like, how Ruby does it. But, like, basically, if you don't have a return statement, it will still return an expression. So, like, if you have, like, just this one line, whatever this line returns will be returned from the function, even if you don't say return. I'm not 100% sure of, like, does it need to just be one line? What if I have multiple statements? I don't really know.
It's the last statement.
It's just the last statement?
Yeah, in fact, it's the last expression. If you want to get into programming language kind of theory, there's this difference between statements and expressions,
So it's the last statement, though.
blah, blah. But it's the last expression.
Cool.
Excellent. So, like, in Python, you have to say return this thing, or it just won't really do anything. Like, maybe it'll change a global variable, so it's still useful. But, like, you have to. And I think pretty much every other language, I don't see this anywhere else. But that's just something to be aware of.
Cool. Does that make sense?
We were like, what is this slide?
Yeah. Yeah, so one thing that this slide points out is that with Python, there's only explicit return statements. You have to say return this thing, otherwise the function it's like a void function in C. In Ruby, there are implicit functions. Watch out for them. If you don't know they exist, they're kind of weird. You might be like, I didn't tell this function to return something, but it did. So this code sort of talks about the implicit, like, Boolean value of different things. So in Python, an empty array, is an empty array true or false?
An empty array is false.
Whereas here an empty array be true.
Yeah, so an empty array is true. Why? I don't know. It just is.
You probably don't need to remember that. Like, I think every language, particularly JavaScript, has, like, some really weird syntactical things, and, like, yeah, they're kind of edge cases that might show up more frequently than others.
Mhm.
Like, I don't think you'll ever need to explicitly use that.
Yeah.
Moving on.
Okay, so this continues on. Wait, what?
Oh, okay. So Well, so Ian, can you describe the difference between like a false and a false value?
Yeah, so when you have a statically typed language, when you have a strongly typed language, that was what I was looking for. When you have a strongly typed language, you have this type which is false, and only false is false. However, there are many other types which are kind of like false. So when you stick them in an if statement, they will be treated as though they are false. This is somewhat equivalent to like saying if character in a C program or if integer. An integer is not a Boolean, but we're just checking if it's 0. Similarly, we can just check if it's an empty string, if empty string. And so in that case, an empty string is a false C value. And I guess what we're getting at here is different languages consider different things false C values. For instance, an empty string is a false C value. In Python, one might expect an empty list to be a false C value. But in Ruby, it's not, apparently. Is that what we just learned? Yeah, I know like all the true and false values for Python, but for Ruby I don't have it all memorized. But anyways, so truthiness and falsiness is kind of a silly way to describe the type coercion, the checking what you do to make sure that the value is what you expect, that you can stick something in an if statement and expect it to run.
Yeah.
Zero false.
What?
A 0 false.
Yeah, 0 is a great example of a false C value.
Okay. In Ruby.
Yeah.
In Ruby, nil and false are the only implicitly falsy values.
Everything else is true.
I
guess
So
You-
0 would have 0 value to true because it's not a descendant.
Google
Yes.
it. Google it.
Okay.
Google it to make sure, just because I don't want to be wrong, because it's
That's a
being
good point,
recorded.
actually.
But no, seriously, look it up.
I'm guessing
right
what
now.
they'll say, like, or the logic behind it is that it is an integer, which like is a thing. I think that the idea here is like things that are things and things that are not things. So like an array is a thing, and this quote is a string, which is a thing, and 0 is an int, which is a thing. And that's kind of Ruby's logic. But
it is not a false C value. It is a truthy value.
Really?
I did not expect that.
That's-
I just explained.
So,
I
good,
can
we were
believe
right, we totally knew that the whole time. So, some people consider this a feature of Ruby. We do not. So, there's a really cool thing. I actually really like this syntax. You can use .empty for things like arrays, strings, I believe that's a dictionary, and double strings. You can basically just, it's sort of like, the syntax is like asking, is this empty? Which is really what you're trying to get at when you put if array. So what you're really trying to ask is this array empty? If it is, do this thing. So Ruby has syntax built around it. This is, we will learn much more about this in the coming minutes and hours. But
Yes, you will be here for that.
don't worry, it's not that bad. Just 5. So Ruby really likes to have like 12 ways to do everything. Maybe more reasonably like 3, but sometimes it's a little too many. In our case, one thing to just keep in mind is if you want to check if an array is empty in an if statement, just use .empty ? And that'll do it.
Yes, you need the question mark.
I guess one thing that's kind of nice about Ruby is that you know that nil and false are the only falsy values, right? With other languages, it's like, is this a falsy value? Let me go Google that. But with Ruby, if you learn those 2, then you know that everything else is true. It's kind of calming. You can sleep at night. If that's what keeps you awake. That doesn't keep me awake. What?
So syntactic sugar, has anyone heard this term before?
Oh, this is really cool. I know.
Wait,
Sorry.
I want to know what he
I've heard it. I think it, well, do you want me to say what I think it is?
Syntactic sugar? Yeah.
Doesn't it have to do with like
Well,
multiple ways of saying the same thing?
Yeah,
Or like, yeah.
pretty much. It's like there's a way to do this already, but here's like a little nicer way, or a way that looks a little nicer, like one that's like 1 line instead of 2.
So like for the return statement where we had sum 5, 3, and it was like you could add parentheses or you didn't really have to. I like it with parentheses. Some people like it without parentheses. We both win.
Yeah, it's not a new feature. It's just a new way to do an old thing.
So one thing that Ruby does that's really cool. What's the name of these again?
Excuse me, what?
It's the string thing, the percent.
Oh,
string
it's a type of string interpolation.
There you go, string interpolation. There's a better name for it, but so yeah, there's basically this really cool thing where you can have an array of things, and if you do %w, uppercase and lowercase, 2 different things, but essentially it interpolates the values inside of it as strings. So you could have A, B, and quote test, or if it's lowercase w, everything is literally like, if it's, that's lowercase, right? If it's lowercase w, everything is interpreted as literally a string. So octothorpe, whatever, curly braces var is literally var. But capital W interprets variables as, that's even though that's a variable, by the way. It interpolates that as a variable and then makes the variable a string. It's just kind of nice for like typecasting. There's a lot of times when you have a thing and you want it to be a string, but or like you have like a for loop and you want every element to be a string and modified like a string. This is just a really easy way to do it. Sorry, I went really long on that. This gets sort of into weird Rubyisms later. Do you want to try this?
No, I want to move on to the next.
We are not very good at Ruby. I'll fully admit that. There are people that are better at Ruby than we are. Not that we're bad. We write it all the time.
Yeah, totally.
But yeah. So some more Ruby stuff.
Okay, so a prop is a procedure or a function. So like you can assign a function to a variable, and then you can pass that variable around. So you can pass processes around like that. Sometimes it's useful. As in, like, I don't know, this example maybe seems kind of self-explanatory. It prints hello. We can pass it here, and then this bar.call. I'm reasonably certain just calls this.
Mhm.
Yeah. So saying foo bar would say like call bar, and then it would come up here and print hello.
Well, call foo, but pass it the argument bar,
Yes.
and then foo calls bar, or calls the function that's passed to it. Sort of like JavaScript a little bit, right? And also Python, passing functions to other functions. Right? Am I wrong in that?
Yeah.
Okay. Blocks.
It's an anonymous function.
Yeah.
How many of you guys have used anonymous functions, like in
Or knows it,
scripting things with?
who here doesn't know what an anonymous function is? 1, 2, 3. Let's cover that.
Okay, so an anonymous function is a function that does not have a name. So like, you know how an anonymous person is someone who like doesn't have a name? That's what the word anonymous means. So basically, anonymous functions are, like I said, they're used really often in JavaScript. So like you'll kind of have these weird nested functions where you'll say like, I want the page to load, and once the page loads, I want you to do these things. So waiting for the page load is its own function, and then within that you would have probably an anonymous function because there's no really reason to give it a name. And so, and especially when you're working with the web, it just takes up memory that you really don't want to be taking up. So that's where I mostly encounter them. Ruby, I guess, also has anonymous functions. So like for this example, it's saying, I want to give you a block, which is an anonymous function, and then just call that. And then it uses that first function to say do. And this is kind of the anonymous part. So like here is kind of where another function's name would be, but instead we're using foo to call this. Does that kind of make sense?
This is just an implementation of the idea of an anonymous function. Anonymous functions are kind of useful in certain edge cases. Most of the time, you're just going to write a function with a name, But in JavaScript, it's used a lot. In Ruby, it's just an option. It's very useful for not including namespace, and it's also useful for just, I only want to do this thing once, really. So I'm just going to make an anonymous function, right? Yeah.
So Chef actually does have its own syntax. However, you can just write Ruby and it will do Chef things. So this is an example of Chef syntax. So this package vim do is saying like, I want you to upgrade the vim package. That's pretty clear, right? Here is a little bit more verbose way of doing pretty much the same thing. So it's saying, I want you to print apt get. So who knows what apt is?
It's the Ubuntu package manager. Who here does not know what a package manager is? Raise your hand. So you're good. You're good.
No worries.
So you use a Mac. So you use like the Mac App Store.
Yes.
So you know how you can just go through them and just say, I want to download this program, right? That's a package manager.
Okay.
Also like Steam, right, for video games. Linux decided a long, long time ago that they didn't want to just have to download source code or super sketchy binaries like Windows does. Instead, they're going to use a way where you can just type into your terminal, install Vim or install Firefox. And it'll go out to a server and say, hey, do you have something called Firefox? And the server's like, yes, I do have something called Firefox. It's like, great, I want that. And then it downloads it and installs it for you totally automatically.
And securely.
And securely.
And important.
There's like GPG, there's like SSH encryption stuff involved. It's just security and ease. So package managers are just super cool. If you have a phone, you've used a package manager before. Each version of Linux, or each family of Linux, there's like Ubuntu, which is like Debian based, and there's CentOS, which is like Red Hat Enterprise Linux based. Don't worry about the differences. They use different package managers. So Ubuntu uses apt, which is just the name. So instead of going to a website and clicking, or an app and saying, I want to download this thing, you would say sudo apt get install Vim or Firefox. Does that make sense?
Yeah.
Cool.
Yeah.
Yeah, it's so cool.
Yeah, so that's like what it's doing here. It's just saying like, get install this thing. So it's the puts apt get is saying like print apt get. And then I'm guessing that this is a variable to the.
It was passed to the function.
Yeah. Passed to the package that you want it to install. So this is kind of a manual way of saying like, I'm going to install something and I'm not going to tell you what it is yet, but like, hold on a sec. I don't know exactly what this is doing. And then this is saying, do that.
I'm not sure why Jordan is doing this, because I think he's going out of his way to say that Ruby can be complicated. But essentially, what you're doing is you're taking
Let's move on. I'm sure this will make more sense in the next few slides.
Okay, if you want, sure.
This
You
will
can also ignore it.
get needlessly confusing because we don't really know how to explain the slides that we didn't write. Sorry about that, guys.
Experts.
Yeah, there we go.
Oh, more syntactic sugar. Instead of using doing, you can use curly braces if you want, but I don't really see that in the wild very much.
Yep. It breaks a lot of like common syntax.
Yeah.
There's like a Ruby standard that's written by the community. It's actually on GitHub. And that's where a lot of syntax, like linters, will actually get their syntax that they implement. So most people will probably say, don't use curly braces. You can, but you really shouldn't.
I thought it was a dictionary thing too. And in fact, that looks like he's using it as a dictionary. Right? Okay, so how many of you guys know what a dictionary is? Most people?
In like Python or C.
So it's kind of like how you think of a normal dictionary, where you have like one thing that's definition, and then, or one thing that's, we call it a key, and then a value. So like if you're looking at a dictionary and you want to define food, you have food and then a definition. It's kind of the same thing. So you have like thing and definition.
It's a collection of keys and values. So you have like you can have a dictionary of people and their ages, right? So I'm Eli. So the key would be Eli, and the value would be 19. And then the key would be Lucy, and the value would be, you're 20, right?
Yeah.
Oh my God, you're 20. So it'd be like Eli, 19, Lucy, 20, something like that. And it's just a really easy way the way that you access it is you say, whatever the dictionary name is, and then brackets, name of person. So most languages have some sort of dictionary. Either it's implemented by you, like in C, or it's built in like
This
Python.
is common dictionary syntax, and I don't know why the above statement completely contradicts that. I'm not sure if this is like Python code. I'm guessing it's not because there's a do end.
No, this is Ruby.
Well, then why? Okay, so maybe you can answer. Why is he saying brackets are equivalent to functions and then using them as a dictionary definition?
Because in some places they are like a function, and in some places they are like a dictionary, and that's the point.
Well, that is just
Yes, you're welcome. When you have them on a single line, like this thing right here, it's like a function. And you can't break, I don't think, you can, I'm not 100% sure on this, but this is my impression. You can break the function over multiple lines, because if you do break into multiple lines, you have to use do and end. But you can use, in other circumstances, if you don't have statements in the middle, and you just have colon separated key value pairs, Ruby knows that this is actually a hash or a dictionary.
that's terrifying.
Ruby is terrifying.
Those are like very different uses.
Yes, you're welcome.
Okay,
Okay.
so
All right.
we are gonna skip that because that's very specific. All of this is very specific.
Well, I think this is like kind of supposed to be hands-on-ish. I don't know if they actually have access to that though. Okay, so a little backstory. At the OSU OSL over the summer, we had this as a lesson for like Learning Chef from our boss, whose name is Jordan. There was a little activity involving some of that, so.
Sorry, we would give you an activity. We had an activity planned, and it was gonna be awesome.
How many of you guys know what OpenStack is? Maybe?
OpenStack? Who doesn't know what OpenStack is? Hands,
OpenStack
good.
is this pretty cool thing, actually. So some companies, or something that's become kind of popular is the idea of, is it infrastructure as a service?
Yeah.
Yes. So kind of the cloud you may have heard of, which is basically saying like, we'll give you server space in exchange for money.
Yeah, so you give us money, and we'll give you cloud. That's so cool.
So you don't have to have stuff on your own machine. You don't have to go out and buy a machine and post stuff on it. You can just buy space on someone else's machine, and they'll make sure it's running, make sure that it stays running, and you just give them money. So like DigitalOcean is another cloud infrastructure. Amazon Web
AWS,
Services,
yeah.
has EC2.
Google, Microsoft,
Yeah.
everyone's getting into
I mean,
it.
lots of people have them. So we use one called OpenStack to host some student, we call them virtual machines, which I think we talked about a little bit. Basically, it was something where you could, through a web interface, access a terminal that we controlled. Like, we could have Chef installed. It'd be really easy. That's what we were planning on doing. And then it didn't work. So
It's probably not our fault, but it probably is our fault. We're not really sure. The judge is out.
anyway, that was a long
yeah.
explanation of what it.
Next week, though, if you do come and you're interested, Nibbleizer, whose real name is Spencer, will be doing an activity on Puppet, which is really cool because then you'll get to see the other side of this. So we're not done with the lesson, but
Well,
just wanted to.
do you guys want to keep going? Do you have any questions? Do you have
Well, we just covered Ruby. We haven't covered any chef stuff.
Yes, true.
So let's keep going. Unless
I also fixed my damn thing.
did you? So it works.
If you want, we can show that at the end, but
Let's do it right now.
just a minute more.
Okay.
It's ready, almost. Oh, I think we were at attributes.
Yeah. So
Okay, so now we're going to get into really chef specific stuff. We know we went over Ruby really in depth, but like now you kind of have some context for chef.
Okay. So when you're running Chef, you have some things you need to think about. There's a lot of moving parts. You need to understand them. Not 100%, although you should. But today we're just going to cover the basics of what each of them is. So you have a cookbook. That's sort of like the glob of code that controls the servers. It's this thing that I don't know what the right word is, but the master basically sends it up to the other servers and says, hey, this is what you should look like. You should have Apache installed, you should have all this installed, follow these instructions to do the thing. And then there's nodes.
Nodes are, again, like the clients that are to be talked to.
Yeah. And then there's roles, which roles are really confusing unless they're not. So you basically need to you basically need to use Chef a lot to get what roles are.
Actually, it's really simple. So Chef can be used to manage many servers, and commonly you'll want your database running on a separate server than your web application. So you'll have a role for all of your database servers, and you'll have another role for all of your web application servers, so they don't get mixed up. And then you can even tell Chef, like, well, we only need a couple database servers, 1 or 2, but we need a dozen web application servers.
I think you know more. Okay.
Roles is different than I thought it was. Never mind. And there's environments. Do you want to go over environments really quick?
Nope.
Cool. Environments might have been what I was thinking about. We will hopefully just stumble upon that answer later. And then there's data bags, which is basically you have a set of variables that you want to reference. Data bags are a way of keeping secrets. So say there's like a database password. You probably don't want to publish that to GitHub. You would put that in a data bag and it would encrypt it so that you could publish it to the web. Not that you should, but you could, and no one would theoretically be able to tell what you were doing unless they like threw a bunch of computing power at it to decrypt your data bag, which would be impressive.
It's kind of like a config file.
But highly unlikely, like a secret config file. So cookbooks. Now we're going to dive into what cookbooks are. So cookbooks have attributes, recipes, templates, definitions, and lightweight resource providers. We won't cover the last two as the slide says, but yeah, we're just going to jump into it. This is something I'm a little more familiar with. Okay, and by familiar, I'm confused by. So attributes are defined inside of cookbooks or nodes or roles or environments. There's 4 levels. Okay, so levels are super confusing. You should Google them. I'm sure there's some table out there that explains exactly what attribute levels are. But there's the default attribute level. And then there's normal, override, and automatic. Basically, that's like, I think those are in level of precedence. So I think a normal will override a default, an override will override a normal, and automatic will override all of them. I think that's how it works. So basically, if you have an instruction, one of them will override another one.
So let's say you have one cookbook that says, hey, I want for there to be a user named this. And the other one says, hey, there needs to not be a user. That's like, there only needs to be one user and it needs to be root and there should be no other users. Then the one with the most precedence will take precedence and be used.
Yep.
Does that make sense?
Okay.
How that conflict could happen.
So attributes are basically variables. So you have this syntax, which is kind of useful. It's cool. So you have your, and hold on, just to go back. We have our levels right here. Default, normal, override, automatic. And in here, we have our attributes, and our attributes are named after, or usually named default. But then when you use them,
You would just reference.
You would reference the node. So if you define it as default, then you use it as a node, which can be a little confusing when you're first writing cookbooks and things aren't working. But essentially, you create a variable by saying default, and then you sort of have namespacing. So you have
the name of your cookbook or the collection. So a cookbook is full of recipes, and a recipe is basically like is it a single file or can it be many files?
Yeah, recipes are single files. Yeah.
Okay, so it's a single file that is used to establish one part of a server's configuration. So let's say that I want a server that has like some really basic stuff. So like we've been talking about Vim and maybe GitHub. Like I want some basic stuff installed, and I want that on a whole bunch of my machines. But then on half of them, I want to have a web application, and on the other half, I want to have a web application with a database. So that database would need to be in a separate recipe, so it's not included in every configuration. Does that kind of make sense?
And then,
So that's how you come down multiple recipes.
yeah, and then for your cookbook, you have a configuration file that has a separate run list. So you have, so say you want to push out the, like say you're doing A/B testing, right? You have one set that's the A testing, and that has a run list of the first recipe, the second recipe, and the third recipe. And then you have a B testing, and that has a run list, which is just the recipes that it uses. And that uses the testing recipe as well as the A, the B, the C. Does that make sense? Or does that not make sense? Okay, cool. So yeah, you define your variables. So you have like a namespace with your cookbook name, and then
In this case, it's a package.
it's a package, but it can be anything. And then you give it a value, and then you can reference that value. So this is super useful. So say you're going to install things into a directory, like a bunch of things, like a bunch of files. You can give this a Linux file path, and then just reference that file path. And just like variables in all code, it's really convenient because then you just change the file path in one area of your code in your attributes file instead of changing it in every single line of every single recipe that you reference that variable. Does that make sense? It's sort of attributes are like recipe or variables for your entire cookbook. And then this is the syntax for creating them. Is this not making sense? Okay, cool. Thumbs up, I love it. And then there's resources.
Oh, so a resource is essentially like a thing that you want your server to have. So it kind of has a list right here of like, say you need a package installed. Again, Vim, the example that we keep going to. Vim would be the resource there. No.
Package would be the resource.
Oh, yes.
You say package, and then here you'd say like package Vim do, and then you'd say like
install, uninstall, update.
action install.
Yeah.
So, and that's how you would,
So there's like a list of options.
yeah, that's how you would like install a package. This is like a super,
General?
yeah, super general case. When we get into more concrete examples and showing different versions of this, or different examples of this, it'll be a little more easy to grasp.
So like other things is you might want to file choose this. So like if you need a configuration file for a certain thing, like you need that to exist. You want that. A template is maybe in the case of web application, you need an HTML template. I don't know what that is.
Well, so a config file, if you wanted to fill in a config file with different variables, perhaps you want to put the host name in the config file. This is what I was just doing. And you want, well, obviously this is going to be run on different hosts. So you need some way to slot it in there. So you have this template config file.
We're gonna get into that in a
And
second.
if you have a slide on embedded Ruby.
We're gonna get to that in a second.
Okay.
There's templates, they're really cool.
But does that make sense with the resources of kind of the idea of like this thing that you were trying to send? Actions being like what you wanted to do, yes. Kind of makes sense.
This will hopefully make more sense later. If it doesn't, just stop it and say, hey, I know we passed by this like 5, 10, 30 minutes ago. I don't actually know what a resource is. Just ask, it's fine. Here we go, awesome example. So in this top line, or top code block, the package is an example of a resource. And then let's just toggle between the two. The name of the package that you want to install is Apache 2. And then the action that you're doing is installing, or the option, I guess, is action and then colon install. That's weird syntax. It's just a thing. I don't know. One sort of syntactic sugar is that if you just say package Apache 2, there's a default action associated with every resource. I believe every resource, or most resources. The default action for packages is Apache 2. So you could just say package and then a list of packages, and it'll just automatically install those.
Or do whatever their default action is.
Sure. Yeah, exactly. But say there's, with like Apache too, Apache is an example of a web server. You don't just want to install it, you also want to enable it or start it up when your computer starts. So you also have to separately say, start it and enable it.
Do people know what Apache is and why it would need to be started and enabled?
Who doesn't know what Apache is? A little shaky. Who knows what a web server is? Who doesn't know what a web server is? Okay, cool. Yeah, it's a program that serves files over the web.
Yeah.
Yeah.
And so if you're bringing up a server, it would need to be started and enabled, I guess, would make sure that it could be started.
Enabled means that it starts on boot,
There you go.
usually. Yes. So yeah, and then with templates, templates are a lot like files.
They're basically
It-
a file.
It's a file, yeah, you're basically taking, you're creating this file, and then you have like a template, which is like a skeleton file with a bunch of variables inside of it. And then you're setting like who owns the file that you're creating, what's the group that owns it, what are the permissions on it, and then notifies.
It would tell the service Apache 2 to restart.
Yeah, once it's created, restart Apache. And then here you set the variables. So this is where you would send, like I said, it's like a skeleton file with foo, bar, baz. Here's where you would say who foo is, here's what bar is, here's what baz is. And use sort of Ruby-esque syntax to denote that. Excuse me. And here's what a template looks like. It's actually really cool. Who here has ever used Jinja from Python? Nobody? Okay. So Jinja is like a Python templating library. Ruby uses like .erb files, and essentially the way you can denote what a variable is with this syntax. You can also denote Ruby actions. You can actually just embed Ruby. That's what ERB stands for, embedded Ruby. And yeah, you can have like for loops or if statements. It's actually really cool. Oh, that slide is just and then, yeah, there's two ways to do variable syntax, but that's super useful for something like a configuration file or any file on a computer that is different depending on the computer it's on, right? So some configuration files are static, but other ones are different depending on the computer they're on. Do you have a good example for that? I'm trying to think of one.
Sorry, say it again.
Files that are different depending on what host they're on.
/etc/host.
There's that. Let me think.
A web server's configuration probably will depend on the domain name. So yeah.
Yeah, there you go. Also, recently I've been working with like Django, and the default directory that the Django application is placed in depends on the system it's on, depending on what options the user gives it. Templating out your configuration file allows the user to say, I want to install this Django application to my home directory or to /opt. And just, it gives you more flexibility when you're deploying your application, which is what configuration management is all about. Yeah.
Here's a little more fleshed out example of declaring an array. And if you guys noticed on the last one, the @ denotes something that's passed in from a recipe, whereas without an @ it is like a local variable. So then we declare that. This is just a regular sentence, I guess. So it's something that's not, like, it'll still be included in the template, but it doesn't need that, like, I need Ruby here in this template. And then I'll print like the first in the array, whatever that fanciness is. Yeah, does that make sense?
We good?
Yeah.
Moving on. So this is an example of the remote file resource. Don't do it.
Oh.
It says should be avoided when possible, so just don't do it. Is that right? Yeah, cool. Yeah, so the reason you wouldn't do this is because you're not templating the file. Configuration management is really useful because you can like have dynamic files that are different depending on the system. That's one reason why you wouldn't want to just place a file somewhere, because you probably don't want that file to be static. Probably, depending on your case. So nodes. Ian, do you want to talk about nodes really quick?
So didn't we mention that there are many clients?
Yeah.
Nodes are just a different name for clients, because in Chefland we call them nodes for whatever reason. And so the data about the configuration of each specific node can be accessed with this fancy tool called Knife. And Knife will be able to spit out the specific configuration values as JSON. And I believe earlier we saw how you could specify did we say that we could specify the configuration for each node in the cookbook?
Yep.
And you're able to change those configuration values using this tool called Knife. So you can say, I'm just going to log into this node and update it so that something will change. I don't have a good example.
So for instance, like at the OSL, that's our like main domain name, and then we have one machine that's called Silk. So then we would say we want to use this chef environment, the production one. So maybe we also have like a development one and a what's it called? Starts with S. Staging. Or
Which is
like a test one.
between development and production.
Yeah, maybe a test one. So that's like the use of multiple chef environments. And then this run list was like what he was talking about for different recipes. So like we want this to be a Jenkins master, so we can host Jenkins on it, and then it can do cool continuous integration stuff. Git. This probably just like installs and sets up Git for the OSL. I don't know what the Slack Rack tables are, but so that kind of makes sense of like node specific configurations and saying like we have this machine, we want it to have this stuff. Yeah.
Would you write this for each one? Like each?
No.
For each, no.
Or is this just specifying a general type?
This is specifying, so like, let's say in your worst dreams, like worst case scenario, you have 4 separate environments, okay? Like not 4 machines, 4 environments. So you have like develop, staging, production, and then, yeah, like another sort of,
We are hopelessly lost right now.
yeah, like pre-staging or pre-develop or whatever like that. This is where you would define those 4, right? So you define what happens in staging, like what recipes get run for the staging environment, what recipes get run for the development environment, what recipes get run for the production environment, and you basically just say like, for development, we don't really need Apache. Like you don't need to have a web server for your development because you're just going to run it locally. But for production, you do want to include Apache. So say this was called development instead of production, you wouldn't include, let's say this recipe. But for production, you do include it. So you don't include this for like 10,000. You don't write a new one for 10,000 machines, just 4. Yeah. And then roles. Ian, do you want to talk about roles?
Yeah, I think I discussed this briefly earlier. Basically, if I have a Drupal server and my Drupal servers rely on my SQL database servers, Drupal just says certain type of PHP web application. I would have a different role for each type of server. Yeah, I think that's fairly self-explanatory.
Does that feel good, everyone? Is that jiving? Is that what the kids say these days? Environments. Ian, do you want to really quickly talk about environments?
I'm good, thank you.
Well, I think it's kind of what we just talked about, where you have a pretty finite list of like potential like places in development where any given machine will be at. So like we just talked about if you have a production environment, development environment, stuff like that. So maybe you're somewhere where you're trying to test out some new recipes. on your servers, maybe that would be called a test environment or a development environment. Whereas in production, you want to know things are working and they're very well tested. So that's going to be your production environment.
Also, with environments, you can set default new attributes. So you have your attributes. You have a whole attributes folder that just says what all the attributes are. But say for production, you want to have some special attribute. I don't know. Attribute value. There you go. But for develop, you don't really care about attribute value. You would set unique attributes for this environment.
Maybe you have a test framework that you need for your test environment, but you don't need it for your production.
Yeah.
Is an example.
Yeah. And then data bags are sort of an implementation of attributes, but excuse me, it's full of secrets. So this is the data bag that you would write. You would write basically a JSON file that just sort of specs out a set of values, keys and values. It's like a dictionary, kind of. So
again, this is for stuff like passwords, or maybe we don't want people to know that, I don't know, that's our internet address, or maybe we are okay with that. Like, they don't necessarily have to be encrypted or secret.
Sorry.
They just can be. But like, this would be our IP address, and then this is what we broadcast over.
These are just
divide like an Ethernet port.
These are just values. These are just keys and values. And this is what you would write, and then you would use knife. What's the tool? There's a data bag tool that you would basically use, and you would say, okay, tool, take this JSON file and create an encrypted data bag out of it. And it would basically take this file and encrypt it so that you can still read, like, well, there's something called device, but the value is like some 64-digit, 64-bit encrypted hash encrypted thing. So the final thing that you would publish to the web would be this, and then everyone internally at your organization would have a key that could decrypt that file. But this is not what you would publish, this is just what you would write, because you need to write something to be encrypted.
So moving on. Is this making sense? This is just really useful for, like, we all have secrets. It's good to, like, not publish those to GitHub, like some people do sometimes. Don't worry about it. So
we talked about this a little bit earlier. Yeah, still on this.
Yep.
So testing a cookbook is in some ways non-trivial. You're essentially trying to test, like, I need you to, like, deploy this thing, and I need in production to deploy it to thousands potentially of machines. But like, I don't have thousands of machines to just test this on. So what test system does is it uses virtual machines to essentially like simulate however many machines you're testing on and make sure that things get installed correctly, files are created, etc. That your configuration management works. And it uses server spec. There's actually a couple of different test frameworks. We talked about server spec. There's also like RSpec and test spec. Basically, all of them are used for writing tests. So you would say, hey, I need you to make sure that this file is here. I think we went over this a little bit in the beginning. So I'll try to be quick. But like, Test Kitchen is really useful for running those tests. Make sure that it works.
Test Kitchen was made because we all don't have 10,000 servers. Most of us just have one laptop, and we would like to test cookbooks that we write before we push them to production. So yeah.
So how many of you guys have written YAML or know what YAML is?
Okay, here's what YAML is. It's JSON without the curly braces.
Who knows what JSON is?
It's that. It's who here has ever written HTML?
Okay.
Okay, cool. So HTML is very similar to XML. Who here has ever written XML? I'm so sorry. XML is just basically a way of defining how do I say it? Like writing information.
Yeah, data.
Data, like
It's a data.
dataing. So first there was like XML, and then there was JSON, which is JavaScript object notation.
Yeah.
And then from JSON was born YAML, because JSON was confusing. YAML uses like white space to denote different things. Holds all your data. You could rewrite this in YAML by pretty much just getting rid of the code bases. Cool. Does that make sense? It's not confusing. That could even be kitchen.json, I think, or kitchen. Yeah.
Yeah, I feel like it's.
We'll just stop there before we start saying wrong things. Hey, great. Here's an example of a YAML file. Isn't so much more readable than JSON?
So for the driver name, that's again your virtual machine. Is going to be manager.
Some options would be Vagrant, OpenStack, or VirtualBox.
We use Vagrant usually.
Vagrant is just a local virtual machine, but OpenStack, like we talked about a little earlier, is like a remote virtual machine.
So if you didn't have a data, like we have a data center kind of laying around. If you didn't have that, you could use OpenStack to be your little data center.
No. OpenStack is like shipping your own data center.
Yeah.
No, like you download OpenStack and run it. We run OpenStack.
Oh, I thought that was unique to us though.
No, that's what OpenStack is.
Oh, okay, never mind.
Quick diatribe really quick. So who here knows what Amazon Web Services is? Has heard of it? It's like, hey, give us some money and we'll give you a server on the cloud. You don't need to manage it. We will manage it for you. Everyone thought, this is great, but I don't trust Amazon, or I don't want to pay Amazon money. I want to use my own. So then there's a really cool open source project called OpenStack, which was basically a way to to ship your own cloud. So it's a program where you have users and projects and virtual machines, and you can spin up a virtual machine and give someone credentials and say, hey, here's your username, here's your password, go. You have a virtual machine now. And a lot of companies use it internally. We use it internally, and also a little bit externally for virtual machines and testing and stuff.
Could you theoretically use a cloud to do test kitchen though?
We do.
Okay.
Yeah. Under driver, we say Vagrant usually for local testing, but we also say OpenStack for remote testing. This is just useful because your computer can only do so much, and you give it a heart attack when you run a virtual machine or 5. Putting it on a data center is really nice, but yeah, besides the point. Provisioner Chef Solo. Chef Solo is basically the program that you use to run your cookbook. This is basically just, it's its own package, right? It does its own thing. It starts up it runs the cookbook, provisions the virtual machine with the cookbook, as opposed to the actual chef model, which is the central server telling a bunch of nodes what to do. So Chef Solo is for testing usually. Hence, it's in Test Kitchen, but then actual Chef has a little bit of a different model. And then platforms, it's basically just which operating systems do you support, and then suites. Run list is where you define which recipes you want to call. And then you have a name. So you have default, but you also have develop and production. And that would just be where you would test, whatever, the default one, the develop one, the production one. For each one, you might have a different run list, and each of these sections has many, many variables, but this is a very simple version. Am I stepping over your feet? Do you want to say anything more? Okay.
This is awesome.
These are kitchen commands. I will quickly run through what each one does. Kitchen list, I believe just lists running virtual machines, or what does it list?
Yeah.
Yes.
Yeah.
Yeah, it
All
lists.
running instances, I think.
Yeah, so if you have 5 virtual machines running, it lists what each of them. Kitchen.
Probably with an IP address, you like SSH to them.
It gives you a bunch of information. Hopefully that's enough. Create, I believe, creates a new project. So it gives you like a template. It creates like a .kitchen.yaml. I believe that's what it does.
Yes.
Destroys a virtual machine that you've already created, which you created probably with Kitchen Converge. And Kitchen Converge is a lot like Vagrant Up. We're starting up a virtual machine, basically creates your virtual machine and then runs your cookbook on the virtual machine. So it takes your block of code, your blocks of code, your thing of code, and says, okay, server or operating system, look like this. Install Apache, install Python, install these. Kitchen Verify is basically running your test suite on the cookbook. So that's super useful because you wrote tests because you didn't want to manually test things. Verify just runs your tests on what's already running. Kitchen setup. It escapes me what this one does. Do you remember? You probably don't need it. Kitchen test is a really cool thing where basically it runs kitchen converge and then kitchen verify and then kitchen destroy. So it's basically a way of saying, does my thing work? I don't really want to touch it if it does. If it doesn't work, don't destroy the virtual machine. So it starts up your virtual machine, runs your blob of code on the machine, provisions it, gets it all ready, and then it runs your test suite. And if it fails the test suite, it says, hey, I failed the test suite. You should maybe look around and see what happened. So you can log into your machine and say, oh, obviously, Apache's not installed, but it's supposed to be because the tests say it does. Oh man, and then you add the Apache cookbook or Apache recipe to your cookbook, and you're set to go. And diagnose does a thing. Probably don't need it. Again, these are all online. If you look up Test Kitchen documentation, you'll find all of this.
Also, just for a tad bit of credibility, I think both of you have been writing cookbooks for almost a year now, right?
Well, I mean, don't say that because then I look worse. I don't know anything.
I'm just saying, like, these are people who have a lot of experience. And so when he says, like, you maybe won't need to use setup or diagnose, it's like, it's not like, oh, we just came across these, I don't know what they are. It's more like, having done this for a year, I haven't used this yet.
Or I used it once.
Yeah.
And I forgot what that was for.
Once you're in an environment, if you decide to get into an environment where you have kitchen installed, running like, I think if you just run kitchen, it'll just print out a help menu. And it'll include all of these. I think if you just run kitchen, it's like,
Yeah.
what are you doing?
Yeah.
Let me tell you what to do. So yeah, is this making sense? Does Test Kitchen make sense? Like, does what Test Kitchen is and why it exists make sense? It's for testing cookbooks at the end of the day. Yeah. Burks file. Burks file is really cool. So
Why would they call it Burke instead of book?
the one good naming choice that all of this has ever made was Burks files. So try to Google for bookshelf. What are you gonna find? What are you gonna find?
Bookshelf.
Right, you're gonna find something like Amazon, like
Or IKEA.
or IKEA. What if you Google for Bookshelf? Probably not as many bookshelves. That's what you're gonna get. So Bookshelf was named because Googling. If you're naming a project that you think is gonna be really big, or you know it's gonna be really big, give it an awesome, easy to Google name. Seriously,
There's actually,
don't be cute. Don't be cute. Yeah.
okay, small tangent, Paul Graham, who knows what Paul Graham / Y Combinator / Macromeans is? Maybe. Okay, so Paul Graham is this very famous like venture capitalist who works in the tech industry. Here in his blog, one of the things he wrote was like how to name your company. And Googleability is one of like the 5 most important attributes. Like, when you're a famous entrepreneur, consider it.
Yeah. When, not if. When. We believe in you. So Bookshelf is really cool. You basically give it a source, which is like, it's a package manager is how I describe them, as going off to a server and finding a thing and giving it back to you and installing it. This is the server, essentially. It's basically where it's gonna ask that source, hey, you have something called Omnibus Updater. You have something called aliases. How about firewall? Unless you specify a separate source, so for example. Here you can specify, I want to install firewall. For something called firewall, and here's where you're going to get it from. You're going to get it from this Git repo, and here's the URL for firewall. Then it's something like Munin, it's going to default to run through the source, I believe. You can also get the version numbers, which is super cool.
And this kind of goes back to the idea of a package manager. So this is essentially the package manager for Chef.
Yep. Who here has done Python stuff? We already asked this.
Pip.
Yeah, kind of. Gem is pip. Like you have a requirements.txt or something like that, and you say pip install -r and then all the requirements for a project. Have you ever done that? If you go to GitHub, huh? Whatever.
Yeah. That's your, okay. I'm not judging.
So with Python packages, you have a requirements.txt. This is sort of like requirements.txt, but a little different because a lot of people, you have a lot more, you can mess with things a little more. You can tell it to get something from a GitHub repo or specify a specific version number, which is super useful when things change and break and you're like, well, 1.7 doesn't work, but what 5 does? You can now get 1.5. So gem files are very similar.
So gem is more Ruby specific, but it's the same idea of being a package manager specific to Ruby. So I guess in this instance.
So like it says, it does a double duty. So gem file, if you have Burks installed, like the gem, it's a gem, Burks, or the program Burks.
Gem is a package. I don't know.
Gem is the package manager for Ruby. If you have a gem file that's not a Burks file, Burks install will just read the gem file. So if that makes sense, because they kind of do the same thing. Yeah. So cool. Tests. So there is actually a very specific file structure for tests. You have a cookbook called My Awesome Cookbook. And then in that directory, you have a directory called tests. And then in tests, you have something called integration. And then inside of integration, you have something called platform. And platform is, what is platform?
Oh, it's like Ubuntu or something. It's, I think.
Yeah, it's like in that YAML file that we specified the platform. And then inside platform, we have test framework. So this would be something like server spec. Server spec is one of the testing frameworks that we talked about earlier. Or RSpec or Chef spec. Chef is like a specific Chef testing framework. And then inside of there, you would have something called myawesometest_spec.rb or Apache_spec.rb, where you would put tests just for Apache stuff.
And then this is an example of like an actual real life test. You can see that we're requiring server specs. This is saying like, hey, we need to use this thing.
Server spec is the testing framework, by the way. So this is a server spec test. They all kind of look the same, but require spec. The sort of way of saying we're using the server spec testing framework.
This is basically saying like, hey, I want to use these two things without, I don't know, saying like server spec dot, I think.
Yep, sure.
And this is saying, we've seen this before, so it's saying I want to make these strings. Who knows what Haskell is? Ooh. So Haskell is a functional language. It was developed for teaching students language fundamentals. So it's something called a meta language, where it's like a language that's good at describing other languages. And actually in programming language fundamentals, which is way further down the CS track, you'll learn Haskell, and they'll use Haskell to like teach you about languages. Anyway, Haskell is a very cool language. If you want to learn it, there's a website called Learn You a Haskell, which is a really great resource. Anyway,
Learn You Haskell.
Learn You a Haskell.
Sorry.
Oh, a Haskell.
Yeah.
Sorry, I need to find this.
No, there's a program called Learn You Node.
Oh, I didn't know that.
Yeah.
That's cool. Is it good?
Yeah, that's pretty good.
Yeah, check out Learn You a Haskell. It's a free ebook. Basically, you can download the like PDF of it. It's Haskell. As a quick diatribe, Haskell is just like a cool thing, just to learn. It's like a new way of thinking about programming. So most of us probably have touched C and very similar C-like syntaxes for programming. Haskell is very different. My go-to example for like, hey, crazy, think about it like this. Haskell doesn't have for loops. I think I can say that. So how would you do a lot of things without for loops? You would do a lot of recursion. Who knows what recursion is, or who doesn't know what recursion is? Okay, cool. So yeah, Haskell like doesn't have for loops. You have to do a lot of things with recursion. So it's just a really cool way to change how you think about programming, and that helps you become a better programmer, even in C, because you've thought about things.
You understand what C is doing. Anyways, so this is saying for both of these things I want to do, and this P is just saying like, I will refer to each of these things as P. So it's kind of like what you guys said earlier with the like type X. So then it's saying this describe is kind of like the testy part. It's saying like, I'm going to tell you what I want this to look like by using the word describe. And then this is basically an English sentence.
Which is why
it actually is a correct English sentence. It should be installed with version.
This is why you would use a testing framework. You could just write functions that run your code and return a given value if it works or doesn't work. But a testing framework, A, is like stupid easy to read.
Like you could just retest without knowing any of server specs documentation and think, yeah, so this is testing to make sure the thing is installed as a version. Like
The executable, so this is talking about permissions, like, so easy, right? So,
sorry to like sound like fanboys, but yeah, it's just very easy to read, very easy to write too. It's the documentation for server spec. If you go to their website, feels a little overwhelming, but then you realize, oh, this page is really long, but there's only like 3 pages, and that's it. Whereas like Chef has like infinite documentation. So it's still not enough. And so testing frameworks are really cool. This is an example of some tests.
which is pretty obvious.
Yeah, so everyone understands what the P is doing, right? Right? Does that make sense? Basically, you can just replace Haskell or P with Haskell for the for loop, and then replace Haskell P with Haskell mid.
It's a cool little Ruby syntax thing.
Yeah.
Test kitchen demo. We are not doing that. Forget that. Yeah.
There might be more after that. What time is it?
8:42.
Wow, high five.
So, are there any questions? Sorry, this wasn't more interactive. Next week there will be a puppet demo, which is gonna be really fun, I think.
Yeah, Spencer is a lot funnier than here,
Also, he's
objectively. So
objectively funnier. You should all come to meet him, just to meet him. Like you can come and then
say
just,
hi. Leave.
or don't leave and just watch him be funny.
Oh, also shameless pitch. How many of you guys have heard of Beaver Bar Camp? Yeah.
How many of you haven't heard of Beaver Bar Camp? Awesome.
So,
Hands.
bar camp is where we all congregate, we eat a lot of food that is provided by the open source lab, and then anybody can give a talk on anything. So last year there was a talk on giving bow ties. 1 year there was a talk on
Tying bow ties, not giving bow ties.
Oh,
I said
tying
giving bow ties.
Here, have a bow tie. There was one on how to make mead 1 year. Obviously it's very text centric. Yeah, you can do. So there's a guy that we know named Jack.
And we work
who,
with him.
Professionally makes mead, and you can just talk, he will chew your ear off about it. It's very tech centric, so like there are a lot of tech talks. There was one about Flask, which is like a Python web application framework. There probably will be one about configuration management at some point.
Probably.
But there's also more, and like you can give a talk if you want. So like, let's say you know a lot about bows and arrows and you want to talk about it. I would go to talk on bows and arrows. So.
And it's totally free form.
It's totally free. There will be breakfast, lunch, and afternoon snack provided. So if food entices you,
Also a barbecue afterwards,
yeah,
thrown by the OSU lug.
yeah.
Um,
So food all day. It's Saturday, April 18th.
Yep.
Saturday, April 18th. That's a week from this Saturday. I know I said to remember dates, but like burn it into your brain.
all day. All day, and it's totally freeform. So you don't need to sign up to give a talk ahead of time. You can just come and there's a board, like a grid of times and rooms, and basically you sign up for a talk in a room at a given time, and then people vote with little like dots, like stickers. And the more stickers you get, the bigger room you get. They'll just move you.
No matter how many stickers you get, you can give your talk. Like,
Yeah.
don't think that you need to be popular or like think of a good talk. Like, use your stickers on your thing. You still get to give the talk.
Yep. And it's just a cool opportunity to like give public speaking and talk to and meet cool people. And
Or just come hang out. You don't have to talk. That's not your thing.
so,
Anyway, and shameless pitch. Thank you.
and shameless pitch, and I think, and DevOps.
And DevOps. Yeah. Any questions?
Thank you all for coming. Any questions before we leave? If you're not on the mailing list, you should join the mailing list. Go to our website, not that. Go to devopsbootcamp.osuosl.org. One more time, devopsbootcamp.osuosl.org. On there, yeah, on there is all of the information about how to sign up for our mailing list, all of the slides. We will make a link to this on the website.
Yes.
You should do that
I should.
because this is not currently on the website. Sorry.
Yeah, this was very last minute, as you could probably tell.
Do you want to do your demo? Yeah. Here's
Let
thing.
me switch off the recording this. If you ever want to like go relive this experience, you can now see it on YouTube. It's okay. I know you all want to. Stop. Oh, that's not what